Resistance. Resistance is a measure of the opposition to the flow of electrical current in a circuit. It is measured in ohms. A good conductor has low resistance. A poor conductor has high resistance. Let's consider some factors that affect resistance. The first one is length. Increasing the length increases its resistance. When the length is doubled, resistance also doubles. If the resistance is doubled, we are going to have more resistance in that conductor. Resistance, therefore, is directly proportional to length. The second one is cross-sectional area. Reducing the cross-sectional area of a conductor increases its resistance. When the cross-section area is halved, resistance doubles. Resistance, therefore, is indirectly proportional or inversely proportional to the area. Temperature also affects the resistance of a material. For metals, resistance increases with temperature. For semiconductors, it decreases with temperature. And the reason why that is so is, as electrons move through a metal conductor, some collide with atoms or other electrons. These collisions cause resistance and generates heat. Heating the metal causes more electrons to vibrate. As a result, the moving electrons collide more with atoms and electrons inside a metal or conductor, and this causes more resistance to the flow of current. The material from which a conductor is made also affects its resistance. Some materials have more tendency to resist the flow of current than others. And that property of a material to have more resistance or not is what we refer to as resistivity. Resistivity is a property of a material which defines resistance of a material having specific dimensions. Resistivity, therefore, is defined as being numerically equal to the resistance of 1 meter length of the material with cross-sectional area 1 meter squared. The symbol for resistivity is rho, and its unit is ohmmeter. From the foregoing, we've seen that resistance is proportional to length and inversely proportional to area. So when we put the two together, we have R, the proportionality sign, length over area. But let's introduce a constant to do away with the proportionality sign. And the constant that is introduced is rho, which is the resistivity. That gives us R is equal to rho times L over A. Resistivity, therefore, is equal to resistance times area all over length. For two conductors made from the same material at a given temperature, they will have the same resistivity. And that relation is very crucial, can help us to solve questions. So if we have a wire or a conductor X, its resistivity is going to be R subscript X times A subscript X all over L subscript X. And for a conductor Y, we are going to have resistance to be R subscript Y times A subscript Y over L subscript Y. Because conductors from the same material have the same resistivity, we can equate the two. And that will give us Rx times Ax over Ls over Ry times Ay over Ly. And knowing this can save you a lot of time when you have questions to solve. Let's bring all these things together as we solve this question. In the circuit shown, resistors are connected between terminals P and Q. The EMF of the battery is 6 volts. We have to state the relationship between 1, the resistance R, and the length L of a wire of constant cross-sectional area. From our discussion, we've seen that resistance is proportional to length. So we have R, the proportionality sign, and length. 2, we have to state a relationship between the resistance R and the cross-sectional area of a wire of constant length. Again, resistance is inversely proportional to area, and that gives us R is proportional to 1 over A. The 12 ohm and 4 ohm resistors are wires of the same length and are made of the same material. We have to calculate the ratio cross-sectional area of 12 ohm resistor over cross-sectional area of 4 ohm resistor. So what we established earlier will come in handy. If they are from the same material, their resistivities will be the same. So we first established that R rho x or rho y is equal to, then we make our substitutions, Rx times Ax over L is equal to Ry times Ay over L. We are not distinguishing the lengths because the question says they have the same length. With that being established, we make our substitutions. The ratio we have to find is the cross-sectional area of the 12 ohm resistor, which we are indicating as A subscript X, and the cross-sectional area of the 4 ohm resistor, which we are indicating as A subscript Y. If we simplify, we are going to get AX over AY is equal to 4 on 12, and that will give us 1 over 3. So the ratio is 1:3. Thank you very much for watching. See you in the next one.